DLSS is a suite of AI-powered graphics techniques that run on the dedicated tensor cores inside GeForce RTX GPUs. Instead of brute-forcing every pixel of every frame at your monitor's native resolution, DLSS lets the game render a lower-resolution base image and then uses a neural network trained on thousands of high-resolution examples to reconstruct a crisper image at higher resolution in real time. DLSS has grown over the years into an umbrella term that covers several related technologies. DLSS Super Resolution, AI upscaling that turns a lower resolution frame into a higher resolution one. DLAA, Deep Learning Anti-Aliasing, uses the same neural network purely for high-quality edge smoothing at native resolution. DLSS Multi-Frame Generation, new in DLSS 4, goes even further, creating up to 3 AI frames for every one game engine frame. For nearly all situations, the answer will be to turn DLSS on. DLSS leverages AI-specific hardware that isn't used elsewhere during the frame rendering process, so turning it on isn't taking resources from something else, and using it can bring serious gains in a game's frame rate. There are some caveats to that advice. Image quality tolerance. Mode choice. Game support. Frame saturation. DLSS requires Nvidia's tensor cores, so it is limited to GeForce RTX GPUs, desktop, laptop, or cloud. Owners of AMD or Intel cards can use rival, open standard alternatives, AMD FSR and Intel CSS, but DLSS is strictly limited to Nvidia RTX cards. DLSS began life in 2019 as a single-purpose upscaler and has since become a full neural rendering pipeline. Whether you crave buttery smooth sports frame rates or want to push path-traced lighting without melting your GPU, DLSS gives you free performance in exchange for tensor core horsepower you already own. And with each new generation, the AI gets smarter, so flipping that little toggle in the options menu is likely to remain one of the biggest instant upgrade buttons in PC gaming for years to come.